Hello everyone, let's talk about another medium problem on Leetcode today, minimum increment to make array unique. In this, we are given an array of integer nums, and in one move, we can pick an index I, where I is greater than equal to 0 and less than equal to nums length. And we have to return the minimum number of moves to make every value in the nums unique. The test cases are generated so that answer fits in a 32-bit integer. Okay, that's a good thing because we are returning int from the function. And then they've given some examples. So in example 1, nums is 1 to 2 and output is 1 because we have to just make the last 2 equal to 3 or this 2 equal to 3, and then everything becomes unique itself. So the important thing is we can only increment, we can't decrement. So for example, we can't make this 1 equal to 0 or something. So we can only increment. I think this was a simpler example. Example 2 is more interesting. In this, we are given an array 3, 2, 1, 2, 1, 7, and the output is 6. Let's see how. So we see 3, which is unique, then 2 is also unique, then 1 is also unique. 2 is occurring again. So to make it unique, we can actually only add values. So next unique element in this list is 4, right? So we make it 4, but the number of moves required for this will be 2. Then we see 1, and to make 1 unique, we have to make it 5, right? Because that is not present so far. So difference is now 4, and 7 is anyways unique. So in total, the output will be 2 plus 4 equal to 6. Now that we have seen these examples, let's jump into the solution space. One of the easiest way to solve this problem is using hash map because the duplicates are involved. So we can actually calculate the frequency of all the numbers and process them one by one. And what I meant by process is like we can process one number and make it unique and then carry or propagate a remaining frequency of those numbers to the next number and do it till we actually reach the end of the map. So let's see how. Suppose our input array has 3 ones and then we have 2 twos and 1 3. So what we will do is we will create the frequency map such that 1 occurs 3 times, 2 occurs 2 times, right? And then 3 occurs once. So in this example, we have 3 ones. So we will use one of them. So the first number we want to process is 1 in this case because in a move, we can actually only increment the number by 1. So as soon as we do, we want to actually start with the smallest number possible and then go towards a larger number. So in this example, we have 3 ones. So we will use one of them in the unique numbers array. Once we use it, we still have 2 ones remaining. So at least our number of moves will be now 2 because both of them will be at least made 2 just to make it unique. But once we make it 2, now we actually remove this key from the map and propagate it to 2, which is already present in the map. So we will just increment the frequency of 2 by 2. If it was not present, then we will just add it to the map. So now we will have 4 twos and 1 3. Once we take 2, we can only take 1 2 at the time. So this part of the array is still unique. So the remaining 2s have to be now converted to 3 because we have to increment them by at least 1. So in terms of number of moves, it will increase by 3. So far our answer is now 5 because of that, 2 from 1 and then 3 from 2. And once we do that, we actually remove this from the map as well and put it into the map with the increased frequency because now we had 3 twos remaining which have to be used and now we will make them 3. That's what we are counting in terms of move. So now frequency of 3 will become 4 now because we had extra 2s from this one and then we just pass it on to the next one. So again, we will use 1 3 from it. So again, our answer actually will increase by 3 because we use one of the 4 3s in the unique array and remaining 3s have to be incremented. Now we will add 4 3s to the map as we incremented extra 3 frequencies of 3 by 1. So now we will add 2 to the moves because now we take one of the 4s, but still 2 2s are remaining that needs to be processed. And once we reach here, then we will remove 4, but now we still have to process 2 5s. And we will just take one of the 5s and only one extra frequency remains. So we will just put 6 into the map with one frequency. Of course, for this 5, we have to still add +1 here. So now when the 6 come in, it is only having one frequency. So it's already unique. So it will not add to the moves. And in terms of number of moves, it will be 2 plus 3 plus 3 plus 2 plus 1. So it will be 11. So that will be our answer in this case. I hope this solution was clear to you. Now let's think about, can we use hash map here? And the answer will be no, because we need some kind of ordering, because once we process one, we need to process the second number, and then we need to process the next number, because we can only increment the number by one. So we need some kind of ordering in place. And which data structure can help us here? It will be Treemap. And now let's jump into the code part. Because the keys are sorted, and we can also use it as a frequency map. Another approach can be that we use min heap and a hash map, but let's stick to tree map for this solution. Now let's see how the code will work. First, we will create tree map containing the frequency, right? So the key will be the number and value will be the number of times the key occurs. Then we will loop on the numbers to create the frequency map. Moves will be our answer, right? So we will just now create the frequency map. I think maybe I can move the moves here. And this will be our answer, which tells us number of moves or the minimum number of moves we have to make the array unique. So till our map is empty, we will try to get the key and value from the map. So we'll get the number. So first key actually returns the lowest key from the map. In this case, it will be the example, for example, I shared was 1, but here also, like if there are 1 to 2, 1, 2 inside, then 1 will be returned, because tree maps are ordered. We'll also get the frequency. Remove method also returns the frequency if the key is present. In our case, we know that actually key is present because we just got it from first key method. And if we have excessive frequency, more than one, so that means this element is not unique, so we need to process it. So we will put num plus 1 into the map, and map.get or default. So if there was already the key present in the map, we need to just increment the value. Otherwise, we will just put the frequency -1 and add the frequency -1 to it. That's it. And in terms of number of moves, it will be frequency -1 as well. And then eventually we just return the moves. Let's run this code. Awesome. Let's submit this code. Cool. In terms of time complexity, it is n log n, where n is the length of the array. And when we are putting the n elements into it, it takes n log n time. And when we are actually removing the element also, that takes n log n time. So that's why overall time complexity will be n log n. In terms of space complexity, it will be O of n, because we are storing n elements at maximum. Actually, it should be m elements, where m is the number of unique elements, but in worst case, it will be equal to n. But can we do better? And the answer is yes. We can actually use sorting. The advantage that sorting gives is that we get all the duplicate elements adjacent to each other, which is easier to process. And let's see how, if we can make some observation. Suppose we have the array like this. We have 1, 1, 2, 2, and 3, 3. Like suppose the array is already sorted. Of course, sorting will take n log n time, but I think we just sort it. And then if you look at first number, so this is already unique, right? So we don't have to do anything with this one. But now, is this number unique? And the answer is no. And we can check it just by looking at the previous element. If the current element is equal to the previous element, that means we have to make a move on the current number. So we increment the current number by 1 and also increment the number of moves by 1. So now it becomes 1, 2, 2, 2, 3, 3, right? So now we can see that, okay, now this is unique and this is our previous element. And now this becomes our current element. So when we look at it, they are again equal. So that means now to make this equal to 3, we will actually again increment our moves by 1. So let's write it down. So our moves are now equal to 2. So now our array becomes 1, 2, 3, 2, 3, 3, right? So now our current element becomes this, and our previous element was 3. So now we can see actually 3 is more than 2, but in sorted array, can it be possible? And the answer is no. So we have to take care of this scenario as well as the scenario when they are equal. So if the previous element is more than equal to the current element, then at least this element has to be difference of these two plus 1. So in this case, the difference of previous and current element is 1. So that leaves 1, and we have to now make it at least 4, right? So we increment it by 2. So our now moves become 4, and our array will become 1, 2, 3, 4, 3, 3. So similarly, now this element has to be incremented by 2 as well, because we have to now make it 5. So it will become 1, 2, 3, 4, 5, 3, right? And now number of moves will become 2. And similarly, if we do it 1, 2, 3, 4, 5, 6 because 3 was already there. So in this case, the number of moves will increment by 3. So in total, we will get like 9 moves, right? So that is our answer. So I hope this solution was clear to you. Now let's code this solution as well. So first thing is we will just sort the array. Now our answers, the number of moves will be initially 0. Then we will just loop onto the array. We loop it from I equal to 1, not I equal to 0, because I equal to 0 will be previous element and it is already unique. So if nums_i, that is the current element, is less than or equal to nums_i minus 1, that is the previous element, that means we have found the duplicate. So we need to fix it because nums_i minus 1 is more. So we will subtract nums_i from it plus 1 because we are incrementing anyways. So to make it bigger just by 1, and also increment the current number by that one. So whatever was nums_i minus 1, we just add it from the previous, and now we will just return the number of moves. Or it should be nums, not num. Let's run the code again. Awesome. Let's submit the code. Cool. In terms of time complexity, this is O of n log n and then O of n time to process it. So overall time complexity is O of n log n. And in terms of space complexity, it is O of 1, right? Because we are not using any auxiliary space or anything. I hope these solutions were easier to understand. And if they help you, please like and subscribe. Have a nice time. Thank you.